All right, everyone. Today we are starting chapter 3. What is it? Day 7 of class. I don't know what day lecture it is. Oh, wait. Everyone take notes really well.
The brightness
It was a joke.
Oh,
I know you can't fucking see it. I'm slowly. Oh my God. Brighter. And I hit one more. Oh, no, that was a nice little increase. That's not too bad. So we're like effectively on day 7. I don't know. I think it's like day 5 of lecture.
yeah.
Lecture day 5. We're starting chapter 3. We're only doing chapter or 3.1 today. Chapter 3 is on numerical measures or numerical summary of data. And 3.1 in specific is on measures of central tendency. That's a mouthful, right? Let's just put it at the start of the lecture where you're going to look in StatCrunch. Rather than having to dig through your notes later on, in StatCrunch, you're going to go stats, summary stats, columns. Rows is an option, but normally we do each row as an individual entry. Like each column being an entry is backwards the way we write things. So we do summary stats, columns. And we'll get to that in a second, but once you get into that subset menu, in there, you first off select the columns that you're working with. Then in the, it's called the stats box. I think it just says statistics. Select the stats you want to see. The summary stats or descriptive stats that you want to see. And then click compute. I got fucking Master of Puppets going through my head. Last Thursday night, one of the girls was wearing AC/DC, so that led to Hell's Bells going through my head. We even played Hell's Bells as a on YouTube as a like the bathroom break. It was exactly, it's 5 minutes and like 7 seconds, so it made a nice good 5-minute timer. There was clearly people in that class, like the evening class has people that are, many of them are like over 30. And some of them I could tell that it wasn't working for them. So after that, I played like a fucking Beatles song so they could have something, you know, a palate cleanser. So let's that's our StatCrunch shit that we're going to use. So before we do it, I want to just like, let's take a moment to recall our 4 major distributions. Oh my gosh, are both green pens in here dead? This is a shitty green pen. Is the other green pen shitty? Let's find out. We had our uniform distribution where all the boxes were about the same height. Then we had 3 charts that looked very similar. One had a hump in the middle.
Stats box.
Stats box, yes. Then we had one where the hump was on the right or left. And then we had a one where the hump was on the right. So this one was called skewed right. This one was called skewed left. And this one is called bell-shaped. Now, these skewed right graphs or these skewed graphs would have columns in them to make them look like this. But if we put a curve over the top of them, we see that it looks something like that. It's skewed looking. So this section is called measures of central tendency. Where do we call the center? Now, on the uniform distribution, center doesn't really mean a whole lot. Like all the data's everywhere. So like when I say where do we call the center, is it like where's the hump? Well, in that case, it would be easy to find. But in general, we don't call it that. In fact, it's going to turn out for both uniform both the uniform distribution and the bell-shaped distribution. Center means center of the graph. It's where the hump is on the bell. And the other one, like it's centered, like they're all about the same height, so you just like pick the center. We're going to do it mathematically in a second.
Progress.
There's three ways we actually check for this kind of thing now. And these words hopefully are familiar to you. Mean, median, and mode. You may not remember what they mean, but hopefully you've heard them before in some lower class in high school or something. Mean is average. So like if I had 5 different people, and we put in siblings. let's say David, I'm gonna call him X1. Andy, Bella, Charlie, and Edgar. I could label these X1, X2, X3, X4, X5. These are just labels to kind of like sort them out. And then the subscript is basically like what position. So if I write XI, I is the order in the entries. It just helps in writing a formula, which we'll do in a second. David's got one sibling. Let's say Andy has 3, Bella's got 2, Charlie's got 2, Edgar's got 2. To calculate the mean, we add up the entries. So add the values. And then divide by total entries. So there were 5 people, we're going to divide by 5. I'm off screen. The notation we use for sample mean is X bar. So I'm going to call this X bar. And population mean is sigma, lowercase sigma. No, it's not. It's fucking mu. I got these Greek letters in my head. Population mean is sigma, or mu. So we would add these up and we would get 10 over 5, which is 2. So the mean number of siblings is 2. So the little formula notation they use, we had XI. What they do is they make this E that looks like a sideways capital M, and they say XI divided by N. N is our sample size. This crazy looking E means add the shit up. That's what it means. Add the shit up. So in this case, we're going to add up the XI. That's how we calculate the mean. I'm gonna make sure everyone's finished writing this. I'm gonna use that same table for median and mode. And then we're actually gonna find the mean, median, and mode of siblings in the class. I'll just go around the room, ask how many people, siblings or brothers and sisters. I'll go around the room asking how many brothers and sisters you'll have. We're gonna do it in Stack Crunch. I'll show you how to use Stack Crunch, all nice, fine, and dandy. And it'll be pretty good. So let's take a look at this for median. What does median mean? The median means the middle value. But they must be organized from low to high. I guess high to low works as well, but there's got to be order. They either got to be all going up or they all got to be going down. I wish I had changed the order of Andy, and in fact, fuck it, I'm changing the order of Andy and Bella real quick. I'm gonna put Andy as two siblings and Bella as 3. Because I think it's important to show that the median is not the number that it shows up as. So what we do is we take the people, we've got 1, 2, 3, 2, 2, and we reorder them. I've got 1, 2, 2, 2, 3. Now, the median is just the middle value. You go in equally the same from both sides. If I did this over here, this says 3. That is not the median. You got to organize them. Thankfully, Stack Crunch is going to do all this shit for you. It's going to do all these operations. But it's important to, if it's a short list and you go eyeballing it, don't do something like this. Here, my sample size was 5. Which is an odd number, and so the odd number median is the center. The center number for odd. If we had one more person, if we have n equals an even, like say 6, I could have 1, 2, 2, 2, 3, and let's say we got someone that's got fucking 9. Now the median, I want to go going evenly from both sides. And now I have 2 in the middle. So when it's an even number, you actually take the mean or average of the middle. The middle 2. So the middle average of the middle 2, in this case, just happens to be 2 plus 2 over 2, which is 4 over 2, which is 2. In fact, this could be even 99. Look at that. I can have a person that had 99 siblings. Maybe they're including step siblings and half siblings and shit like that. Dad's a goddamn tramp. Or he's like super famous and handsome, and so like he gets all the women he wants, and so he has a whole shitload of children. Like everyone's like, I want George Clooney's baby. And so now he could have like hundreds of children and not know it. If he's unfaithful to his wife. I don't know. I don't even know. I assume George Clooney's married. I don't keep up with that shit. So like even if it was 99, the mean is still or the median is still 2. What would the mean be here? Take a second and calculate it out. See if you can figure it out. We're doing 99. Let's see. Maybe we want to change it.
18.6.
Okay. We'll leave it as that. That's not too bad. So if you're calculating it out, you add them up. And divide by the total number of entries, which is 6 now. I've got 6 and 3 is 9 plus 100 is 109 over 6. And when I do 109 divided by 6, how do I make this fucking show? Ah, fuck it. I'm not. This says 18.16666666667. I would probably round this to 2 decimal places as 18.17. So this would be my X bar. Oftentimes they use M for median in mathematics. But in social sciences, M is mean. So it's like there's some inconsistency depending on what field is using it. Okay. Well, so notice adding one more. That was completely different than the rest. Than the rest. The mean changed a lot. Median, not at all. And sometimes it does change, but it barely changes sometimes. Now it's Enter Sandman. I don't know what will be next. Which Metallica song will be next? For Whom the Bell Tolls. Disposable Heroes. I like Disposable Heroes. Okay, so this has a name. Well, there's a couple of vocabulary terms here. One of them is when one data piece is drastically different than the rest. We call it an outlier. That's a vocab term I am going to use a lot this semester. Outlier. If we're talking about income, Elon Musk is an outlier in damn near every group of people on the planet. There's only a couple groups that he fits in with, and they gotta be like the rich motherfuckers too, like Warren Buffett and shit like that. Everybody else, we don't look like shit. So that's one vocabulary term. The other I want to use is for this. When a summary stat or descriptive stat is not really affected by outliers. We say it is resistant. It resists the influence of outliers. In the examples we had with median and mean, median is resistant. Mean is not resistant. I'm going to go over mode in a second, but generally mode is not used for central position. Thank you. And when the areas mode works for, we'll talk about when we get to mode. So generally it's between mean and median. So let's look at our uniform is kind of like a shitty group to look at. So I'm going to look at our bell curve. We're going to look at our skewed left graph and our skewed right graph. And show where means and medians are here. So this is my left, this is my skewed right, and this is my bell. Michelle, my bell, these are words that go together well. All right, so for the bell curve, the mean and the median are in the same spot. Maybe I'll do median in blue and mean in red. Now, the median tends to be closer to the hump on both of them, the skew graphs, than the mean. The mean tends to be further away from the hump. So if the hump is here, the median is closer to the hump. So median is our preferred choice. Median is the preferred choice for central tendency. Because it works on all of them. Now, I'm sure you're going to have a homework problem that asks you about this left and right shit and asks you how the average and medians compare. So don't forget inequality symbols, what they mean. The one on the left is always less than the one on the right. So for skewed graphs, skewed left, the mean is less than the median. Or we could say median is greater than the mean. They'll say it two ways. And on skewed right, you flip that order. Median is less than the mean. Or mean is greater than median. I think of the shit. I'll just fucking leave it like that. Oh, the fuck happened? There we go. I think the graphical thing is easier to remember, to be honest. This is a pain in the ass to try to remember which one's which. But if you always remember the median is closer to the hump, and you know what less than and greater than mean, you can always like sketch this out and like do it. And it worked, that's one sentence works for them all. Median is closer to the hump. Anybody remember what mode is? Mode is the response that shows up the most. It's exactly correct. So on that list of siblings, the 1, 2, 2, 2, 3, 99, 2 shows up the most. The mode is 2. In this the case, it happened to be the same thing as the median, but usually it has nothing to do with it. If they are all unique responses, like every answer is different, there is no mode. If we have a tie between 2, they call it bimodal. And a tie between more than 2 is called multimodal. That's the only ever time you're ever going to hear me talk about mode. I'm not going to use mode for any other chat the entire semester. Where do we use this? This is used for qualitative data. Because the mean and median are meaningless for categorical data. Categorical or qualitative data. We wouldn't talk about a median eye color or an average eye color. That just doesn't make any sense. What we could talk about is the eye color that shows up the most often, which for as a non-brown-eyed person, I like to call shit brown. Just because my brother's got brown eyes and I got blue. You got brown eyes, you're probably like, no, I don't call it shit brown. Fuck you, Jones. But like that has meaning. Like, but saying like the mean eye color, the average eye color, that doesn't make any sense. So we use mode for categorical data. Before I show you it in StatCrunch, there's one more thing I want to point out. These are 2 different bell shapes. But the mean and the median are the same. And the reason why I point this out to you is it's to illustrate the center doesn't tell us everything about the data. Like one of these is more spread out than the other. The word we use for spread is called dispersion or deviation. And this is what we're going to do on Thursday in 3.2. So having the center and some way to measure the dispersion or how spread out the data is. Like if this is a pile of sand, the tall one's got the sands all humped up in one spot in the sandbox. This one, the sand's kind of spread out a lot. There's still a hump, but it's nowhere near as big. The sand is deeper everywhere. And we're going to go look at StatCrunch. Like, how do we do this in StatCrunch? Talked about it already. It's stats, summary stats, columns. Should be at the front of your notes if you did it, but since I'm about to jump to it now, just need a reminder before we put it up on the screen. We'll do it. And we'll let you guys bounce. That's not fist pump worthy. The hell is this bullshit? You're supposed to say, no, Mr. Jones. I want to be here. Just give us more. Right? No one's fucking agreeing with me. That's just cold. All right, you guys ready to take a look at the stuff in StatCrunch? Oh, fuck off with your bad gateway. All right, let's do one called siblings. I have one. Let's go around the room and see how many siblings each person has. I'm gonna go start here, go that way, and then we'll go down those. How many brothers and sisters do you have? 3. 3. All right. Yep.
6. 2.
Next.
2. 6.
The fuck? Let's go with you. 2. How many? 3.
1. 2. 4.
up front.
Oh, one.
Bunch of breeders in this house.
Three.
The fuck, there's like a full row. I've never seen this. There's two fucking full rows. Normally people spread out and it's the same fucking row. What the hell is going on here? All right, next person. 3, 2. There it is. I knew someone had no brothers. That's everybody. All right, so. How do we, maybe we could ask, Brittany, since I meant to, thanks for responding, guys. We got a 2 and we got a 9. Really? Because there was a fucking 8 in here and no one fucking gasped. All of a sudden, 9's too much?
Yeah, because someone's 10 kids told us.
Right. That's too far?
Yeah.
Like 2 digits.
You fucking draw the line and you guys have it.
I'm assuming.
Like my cousin, she has 9 kids, but like 5 of them are hers and 4 of them are through marriage. Now, that might be the circumstance here. There might be like someone that is like, mom's just fucking been a full-time like mom. Before we jump over to the stuff, let's just look at a frequency distribution of this. Like, let's try to get a feel for what this looks like. So what kind of graph would we call that?
Histogram.
You're right, it's a histogram. Is it a uniform? Is it bell graph, skewed left, skewed right? I'm hearing 2 different ones. I'm hearing skewed left and skewed right. So this is skewed right. Now, the way I remember it for everyone that said skewed left, I'm with you. I see the fucking hump and I go, that's where it's skewed to. That in my head is what it should be. But that's not what it is. So you're just gonna have to tell yourself whatever feels instinctively correct is fucking wrong. That's how I had to do it with this shit for like a year and a half teaching it. And now I do not fuck it up. For a little while there in the beginning, I fucked it up and said it wrong because I look at the hump and that's where I want to say it's skewed to. No, it goes on, it's the length of the tails or where the long strips are. It's kind of like, where are the outliers at? That's another way of looking at skewed. It's where are the outliers at? Now, this broke it down into every 2. See how it goes 0, 2, 4? Let's change that shit. I don't know why it's averaging it out. I want to do every 1. There we go. Now we've got, this is 6 people. Oh, no, it's 4 to 5, so that's 4 people. Here's 5, here's 6, here's our 8 and our 9. Here's our little 0. Now let's look at our summary stats. Now, since this is skewed right, the median should be closer to this hump. Do I have an option of showing the hump? I do, look at this. I can show the median and the mean. Median is going to be the red line and the marker mean is going to be the green line. The median is closer to the center of that little curve than the mean. In fact, when you do it on that graph, you can put your little cursor over it and I'll tell you what it is. Do they have an option of laying the curve over it? Overlay distribution. Normal? Nope. Let's take off that. Get rid of that. That doesn't look good. Okay. So that's what our data looks like with the frequency distribution. let's come over here to stats, summary stats, columns. So this is the new command for today. Click on the column you want. If you want more than one column, click on more than one column. A bunch of these in the statistics box are already selected, okay? We haven't talked about standard deviation or variance yet. We will talk about them later. We've got mean, we've got median, and I can just choose them now. And we've got, where's mode? Mode's usually at the bottom because it's the one people don't care about. So the mean is 3.26667. We can see that on our histogram. The median is 3. And there's only, I would say this is bimodal, but they don't do that in StatCrunch. They either say the mode is or it's multimodal. They don't distinguish between bimodal and multimodal. But there it is. Why do I have a gap there? Let's just move that there and delete that one. There we go. That's it. That's all we got. Stats, summary stats, columns. We're gonna be doing a lot of stuff with this chapter or this section, all of chapter 3. And you'll look at it in, well, no, you'll be able to like pull up these things, these summary stats a lot later on. I'll remind you of them on occasion as we go through the semester, but where you're using them a lot for the homework is just chapter 3. Have a good day. You're free to stay here and work on homework if you'd like, or you are free to GTFO. Take your pick. Peace. What?
You know,
Yeah.
I'm just don't understand what's going on.